In this part of the computational intelligence course related to fuzzy systems, we will continue fuzzy relations. We will cover projection of a fuzzy relation onto a subsequence of reference sets on which fuzzy relation is defined. We will then see the definition of Cartesian product on fuzzy sets. Consider the Cartesian product of all sets in the family. That is, we are considering xi. I is element of integers of dimension 1, 2, up to n. For each sequence n tuple x having elements x1 up to xn is element of the Cartesian product of the universe of this course. I start from 1 up to going up to n. And each sequence R tuple where R is less than n, we are saying that Y is an R tuple of Y's, and this is element of the Cartesian product of some universe of this course defined in set J, where J is a subset of n and the size of the J is R. So we are considering a subset of the Cartesian product here, and on that one, that tuple is defined. Y is called subsequence of x if and only if the value of yj is exactly same as the value of xj for j element of set j. And this symbol denotes that y is subsequence of x. Y is subsequence of x. For example, let n be 3. We have tuples x1, x2, x3 as x. Then, for example, a subsequence maybe as j, we are selecting 1 and 3. 2 is not in the set j. Then the subsequence is considering this one, x1 and x3. And for example, if the values are 0.1 and 0.3, for example, for x2 and 0.5, then we will have the same value, 0.1 for x1 and 0.5 for x3. Whatever the value here is same as in the subsequence. Given a relation R on tuple x1 up to xn, let this relation denote the projection of the relation R on Y. So this is a projection relation between R and Y, where R is also a relation itself. It disregards all sets in X except those in the family. So let Y be such that it is containing some of the universe of this course defined for X. The relation is defined on X, and we are considering a subsequence of those tuples, and we are trying to find the projection on that one. Then our projection on Y is a fuzzy relation whose membership function is defined on the Cartesian product of the sets in Y. The projection of R onto Y at point Y, we are considering the maximum value in X and we are assigning that value as the result of the projection. Note YE is a subsequence of X. Here Y is a subsequence X, and on that subsequence we are trying to find the projection. Under special circumstances, this projection can be generalized by replacing the maximum operator by another operation, T conorm. So we have T norm, for example, minimum value can be used as T norm, and also we have T conorm. This symbol is used for T conorm, and for example, maximum may be used for this purpose, and T is used for representing T norm. Consider this one. For example, if our space has X and Y, and if we consider this relation on XY, this is the fuzzy relation, and the projection of this relation on X, for each point, consider the value of the relation by changing Y, and take the maximum value and assign as the value of the projection. So this is the projection of this relation on X. And again, if we consider this relation, then this is the projection of this relation on Y. Consider the sets. X1 is containing 0 and 1. X2 is containing 0 and 1. X3 is containing 0, 1, 2. And the ternary fuzzy relation on X1, Cartesian product, X2, Cartesian product, X3, defined as follows. Let Rij is the projection of R on Xi, Xj, and Ri to be projection on Xi for all I, J element of 1, 2, 3. Using this notation, all possible projections of R are given below. Suppose that the given relation is this one. For any combination of x1, x2, x3, the relation has a membership value. So we have 0, 0, 0, membership is 0.4 for the relation R, and we are keeping this to the same, changing x3, so 0, 1, 2, and for each combination we have a value 0.4, 0.9, and 0.2. And then we are changing x2, so we have 0, 1 here for all these rows. Again, we are changing x3 to 0, 1, 2. And then we have 1, 0 for x1, x2. And we are changing again x3 from 0 to 2. So in this way, we have all possible combinations of x1, x2, x3. x1 has 2 elements, x2 has 2 elements, x3 has 3 elements. So 2 multiplied by 2 multiplied by 3, we have 12 rows here. And for each combination, the relation has a value between 0 and 1. Then, for example, we are going to find out what is the projection of R onto R12. R12 is saying that projection to x1, x2 combination here. For this purpose, notice that we are considering x1 and x2, and x3 is eliminated. We are trying to find projection on 1, 2. So consider these 3 while x3 is changing, while x1, x2 is constant. So for the point x1, x2, 0, 0, we are considering these three values and we are assigning the maximum value as the value of the projection. So if you project this onto x1, x2, this value is projected, take the maximum, so the value is 0.9. And for x1, x2, 0, 1, here for 0, 1, we are considering all possible values of x3, and for those, we are considering the value of the relation, membership value of the relation, and we are taking the maximum one. So we have 1, 0 for x1 is 0 and x2 is 1. And similarly, for x1, x2, 1, 0, here we have values 0.5, 0.3, and 0.1. So we are taking the maximum. The value assigned is 0.5. For last combination of x1, x2, then we have 1, 1, and 3 different values for x3. The maximum value of the relation is 1, 0. So the value of the relation is 1, 0. And for example, if we are considering projection on R1, here the value of x1 is either 0 or 1, and while the others are changing, here we are keeping x1 constant, and x2, x3 are changing, and we are considering all this for x1 is 0, and we are taking the maximum one, which is 1, 0. So the value of the projection to x1 is 0 for this entries for x1 equal to 1. And for this example, also the maximum for the second part is 1. So we have value 1 for the second part. And for projection, for example, onto x2, we have to consider the rows for which the value of x2 is 0. And we have 0.4, 0.9, 0.2. We are going to choose the maximum. And also here we have x2 as 0. Consider also these entries. The maximum is this one, 0.9. So for x2 equal to 0, we have 0.9 as the value. Here also shown. For a detailed explanation, consider only the projection R12. Here we have all possible combinations of x1, x2, x3. The relation has values 0.4, 0.9, 0.2. And for the point R12, x1, 0, x2, 0, for these cases, we are taking the elements relation 0, 0, 0, relation 0, 0, 1, relation 0, 0, 2. These are the values. And we are choosing the maximum one. So the value is 0.9 for these combinations. And similarly, as it is explained previously, the maximum value is considered as the value of the projection. For these three, maximum is 0.5, and for those, the maximum is 1, 0. So the projection has value 1, 0.